So here we are in my backyard. Does this look like my backyard? I've never seen my yard look like this, but we are here at Keene State College, and Keene State College and the Surrey Village Charter School have been doing some research on eggs and resveratrol and all kinds of different things. Today we're going to see what their process is, see some of the instruments that you folks use, and then, don't tell anybody because everybody at Keene State's going to be over here, we're going to try some knotweed pie. Did you hear that? Knotweed pie. No, I hear that it sounds, or it tastes like rhubarb. So I'm really looking forward to it. The Surrey Village Charter School students will be here soon with their advisor, and we'll have a taste. So right now I think Denise is going to help us to understand a little bit more about the process,
right?
And then we'll go from there.
Well, this project couldn't start without an egg, and these eggs are fed Japanese knotweed and then collected by the students at the Surrey Charter School here in town. When they come to Keene State College, the first thing we have to do is to separate the egg, which means all we're going to do is to analyze the actual egg yolk. And then what I'm going to try to do is to take you through kind of a generalized procedure as to how we get the egg yolk ready for analysis. And the first thing we need to do is to measure out a certain amount of the yolk that is going to be dependent on whatever type of experiment we're going to do. So that is what I've kind of shown you here in this test tube. And then once we have the yolk measured out, the next thing we do is we introduce a solvent to the egg yolk. And what the solvent's going to do is it's going to literally pull out or extract a wide variety of different types of chemicals that are found commonly in the egg yolk. So here we're just going to take a few samples of solvent.
And what would the solvent be this time?
We're actually using ethyl acetate in this case, and that's the solvent that we use for the resveratrol analysis that we've been doing. It is a component from nail polish remover, so you might generate, the smell kind of gets to you a little bit.
Now, did you, when you were putting this in, did you measure how much the solvent you had in there, or does it matter?
Yeah, so for the case of like the resveratrol experiments, we use 1 gram of egg yolk, and what we do is we extract it with 2 milliliters of the ethyl acetate solution. One thing you'll notice here is that once the solvent is actually added to the egg yolk, the solvent is still colorless. And then what we need to do is to mix these two together so that we can pull out all of the chemicals from the egg yolk. And in order to do that, we use a device known as a vortex. So if I just kind of hold this down for just a minute or so.
This could be great for kids on campus
Oh,
with drinks and...
Lots of kids like this. But you know, if you kind of can take a look at it, what's actually happening is the solvent is starting to turn yellow. So what is actually happening here are certain chemicals that are found in the egg yolk are actually being transferred or pulled into that organic solvent layer.
So is that what you're going to be looking at more so than just the specific egg yolk?
Right. So we leave behind all the other larger molecules, the proteins and stuff that are found in the egg, and all we're trying to do is just to isolate specific molecules in order to analyze them further.
Excellent.
Once we do this extraction process, we then do another process where we derivatize different types of molecules that are found in the egg yolk.
And what does derivatize mean?
So many of the molecules that we are trying to analyze are either too polar or they are too large for a lot of our instruments to detect. So what we do is we chemically transform them into other substances. So for example, for the resveratrol, it has a lot of oxygen-hydrogen bonds in it, which are very polar. So you can kind of think of them as that they're kind of really sticky. So what we do is we remove the hydrogen and we replace it with a silicon atom. And now that molecule is less polar, and then we can actually use the instruments in our lab in order to analyze them. In the case of when we do the fatty acids, many of the fatty acids found in egg yolks are found as triglycerides, which are 3 fatty acid molecules attached to a 3-carboned glycerol chain. And again, those molecules are too large. So what we do is a process known as transesterification, which clips each one of them off, and then we can analyze them independently from one another.
Interesting.
So once the vortex phase has been over, Now, this is a part which I'm not actually showing you here, but this is where we would add the chemicals that would allow us to transform the molecules that we want to study into their more preferred forms. And a lot of times those processes also involve a heating phase to it as well in order to complete the reaction. But once that part's done, we then come over and we use what is known as a centrifuge. And you'll notice, you know, you have a liquid layer, but then there's still a lot of solid material that remains from the yolk. And what we're really only after is just the liquid component to it. So what we'll actually do is to take this instrument, which spins the test tube at very high speeds, and it literally just forces the solid material to the bottom of the test tube so that we can easily remove them from one another. So if we actually take a look at it now we kind of have a much larger liquid layer,
Right.
and all of the solid material has been pushed to the bottom.
Nice.
Okay. And now once we're at this phase, now we're ready to prepare for analysis. So since we are using our gas chromatograph mass spectrometer, what we need to do is to transfer our samples into small sample vials. And usually what we'll do is we'll take a small aliquot from here, like so. And then what we'll do is we'll add more solvent to it to bring it up to a certain volume.
I feel like I'm back in school.
It's the fun part of school.
Yeah.
So now we have an egg sample to analyze on our instruments.
Wow. You'd never think that that was an egg.
I know.
All right. So we're going to go in and use the, what is it
Gas
called again?
chromatograph mass spectrometer.
Excellent.
With
Say that
Shannon.
3 times fast.
Gas chromatograph.
All right. So we'll see you at the mass.
Gas chromatograph mass spectrometer.
Okay, sounds good. So we're here at the GCMS. And what are we going to use this for?
Okay, what we use this instrument for is now that we have our sample, we can use it to analyze the fatty acids and look for resveratrol in the eggs by using this instrument. What we do is we take this sample that Denise had just prepared for us, and we can put it into the auto sampler, which can hold a number of different vials in it. And what the instrument will do is there's a syringe in this injection port, and it will take the sample that we want to analyze and inject it into the gas chromatograph part of our instrument. And here's where the instrument then can go through a column and separate. And this oven is kept at a high temperature, which will easily volatilize our sample into the gas phase. So then as it separates down the column, we can analyze the different fatty acids on their own. And then once the sample gets to the mass spectrometer part of the instrument, which is over here, this is where we can test for the mass of the different molecules that we're looking for. So the different masses will help us identify the fatty acids, whether they're saturated or unsaturated, and it's also been optimized to help us really focus to find resveratrol in the samples as well.
Right. So as Shannon said, we're using the instrument for 2 different purposes. One, to measure these fatty acids, and ultimately to measure a ratio of the unsaturated to saturated fatty acids. The higher that ratio becomes, the more healthy we believe those eggs are. So we've generated a set of results from some eggs that were produced last summer, and we showed higher ratios of saturated to unsaturated for eggs that came from chickens who were fed Japanese knotweed. The ratio was 1.87 for, 1.82 for eggs from Japanese knotweed fed chickens, and 1.67 for eggs from non-Japanese knotweed fed chickens.
So there really was a difference.
There really was, and
Yeah.
we used some statistics to show that that was significant. It was on a limited number of eggs. We're really excited to get back into the research this summer once the knotweed comes out of the ground and the chickens are laying a bunch of eggs again.
Yep.
But as Shannon mentioned, our current focus here is to use this instrument in a slightly different configuration to search for resveratrol in the eggs. And we configure the mass spec to specifically look for resveratrol at its current mass.
And let me, before we go on, some of the people out there may not know what resveratrol is. If they didn't see our show earlier, resveratrol is a chemical that is used to, let's see, help ward off cancers. It is a chemical that can help you lose weight, and it can also help you with anti-aging. These are some of the things that they've brought up in scientific research. So the reason that we're doing this research is to learn to see if the eggs fed, or the chickens that are fed knotweed, will transfer the resveratrol into the eggs, and then when we consume them, if those will be better for us. So this is very interesting research that Keene State College is doing, again, along with the Surrey Village Charter School. So please tell us more.
Right, there's really several benefits that humans can obtain by eating eggs from chickens who are fed knotweed. One is the presence of resveratrol. If we can consume more of this antioxidant that we already know is good for us, that can give better health benefits. We all know that omega-3 fatty acids are important for us. They're difficult to obtain from food sources, and you see marketing on egg packaging for more and more more and more levels of these omega-3 fatty acids.
Right.
We've shown in our analysis here at Keene State that eggs produced from chickens who are fed knotweed show 260% increase in DHA, this important omega-3 fatty acid, and a 90% increase in ALA, another important omega-3 fatty acid.
Isn't that incredible? You know, who would have ever thought?
Right.
You know, if this research wasn't started, I'm sure other people are, you know, possibly looking at it. But I think this is so cool to be having you guys do this here at Keene State College.
It's been really rewarding.
And with you, Shannon. I mean,
Yeah, it's very easy to get passionate in this kind of
Right.
project that can benefit other people if we find good data and
Right.
good results from
Right,
this,
right.
which
And
we have been.
Yeah, and resveratrol can be found in the skin of grapes too, because
Yeah.
people drink red wine, and red wine is good for you for that reason as well. So, you know, it's just really, it's interesting because eggs are something that most people will eat every day, and almost, you know, every day you'll have some product that has an egg in it.
That's right.
Yeah.
That's right.
Yeah. So you have some slides that you wanted to show us too?
To give a little bit more information
Okay.
about how we're making this determination. Saturated fatty acids will break apart halfway through this instrument. So after we separate through the column,
Okay.
the molecules then break apart before we read their masses. The pieces of those molecules are what we use to characterize a chemical and say, oh, this was an unsaturated fatty acid, or this was a saturated fatty acid. And there are particular masses. If it's an unsaturated fatty acid, we'll see a 55, a 67, or a 79 mass per charge value. If it's unsaturated, we'll see a 74. So Shannon will analyze the data after it's been collected and calculate these ratios for the different eggs. So we're looking at patterns of the chemicals that when they break apart after they've separated down this column. So at the moment, we actually been generating results just this past week. We have some eggs that were produced from chickens over this quite mild winter. And the Surrey students actually gave the chickens a Japanese knotweed tea. And we've been analyzing those eggs again to see how those the ratios of fatty acids might change, and also to look for the presence of resveratrol. And we're really excited to say that we believe we're seeing resveratrol in these eggs, but before we jump up and down and tell everybody, it's important to run careful controls, and also to see that it's not in eggs that were not fed Japanese knotweed.
Right, you have to have that control.
We do, we do. And there's really a seasonal aspect to this project, right? So we're waiting for the knotweed to come out of the ground, and we really are excited to jump into this with more vigor this summer, greater numbers of eggs, more students involved, and probably a new student here at Keene State, because Shannon's going on to do things at University of Kansas this summer. So.
Excellent, yeah. Well, at least you started it.
Yeah.
Good. Okay, that was really interesting. So, oh, wow, the Surrey Village Charter School is here. What do you have? You have the pie.
Yes.
That is so cool. Well, let's take a look at that. You guys, right down here. All right. So, this looks like a regular pie.
It's strawberry knotweed pie.
Strawberry knotweed pie. Doesn't that sound delicious? I have never tasted it, but I know that it's going to be delicious. I know you guys were talking about it last year when we had our meeting before. So I am really interested in trying this. Are you guys interested? Have you guys tasted this?
Yeah.
Yeah.
We have.
And did you like it?
Yeah, it was really good.
What other stuff have you guys made out of the knotweed?
Well, we did try a knotweed sauce, kind of like applesauce.
Uh-huh.
That didn't work as well as the pie, but it was still pretty good.
Yeah.
And we also made knotweed tea.
Mmm. Now, the applesauce, was that good warm or cold?
It was much better cold.
Yeah.
Definitely.
Yep. Now that is beautiful. Let me take it up before it falls. There we go. And we have a fork here. And we have a recipe for anybody that is interested in trying to make a knotweed pie. This, again, is strawberry knotweed. It takes a cup of sugar, tapioca, cinnamon, knotweed, strawberries, and a pie crust. I mean, it's pretty simple. So we'll put that up on our show screen. I'm just going to taste a little bite of it. Do you mind? Okay. That is really good. I know, it's hard to believe knotweed of all things, but this is really tasty. So I'll let you guys take a taste as well, so that you have an idea. Okay, and you can pass those around. So we've been here at Keene State College with the students from Keene State Shannon.
Thank you.
We've had Denise and Jim, and then all the students that are here are from the Surrey Village Charter School. They're sharing their pie with us today, all in my backyard. So if you're interested in information about In My Backyard, you can email us at inmybackyardch8@gmail.com, and we'd be happy to get back to you. So thanks a lot, and thanks for joining us in my backyard. Dig into that pie. Oh, I know you guys. Oh, you got one? Okay.
We have more pieces.
Oops, I got so many hair there.
It really is tasty.
That is good.
Isn't it? Yeah. I would never think.
Yeah, it's quite good.
It is. Oh, and seconds. You guys can have your own piece.
Thank you very much for bringing that.
Yeah, thank you.